Hi, welcome back to our Intro to Functions and Function Notation. This is our fourth video on this topic, and today what we're going to do is to find out what is a modulus function. Already in this chapter, we have learned what some key terms are: function, domain, range. We've talked about what is the definition of a function, why is it a function, and we've looked at some of the basic notation ideas. Then we've talked about composite functions and how to notate those and how to solve those. And today what we want to do is we want to start to understand what does it mean if you have something that is a modulus function, and how do we solve these kinds of equations. We can solve them algebraically or we can solve them graphically, but this lesson is going to be about how we solve them algebraically. And then next lesson we'll talk about how we solve them graphically. I would recommend that you get your notebooks and open up to a new page and put the date and write down our title, 1.4 Modulus Functions. If you need to pause the video so that you can do that, go ahead and pause it if you need to. What we're writing down is we're going to write down some notes that are on this slide. That a modulus function can also be known as absolute value. What we want to find out is what is the size of something, or what is the magnitude of that thing, without necessarily thinking about the direction. A modulus function would be written inside of modulus signs. Modulus signs are straight up and down lines. They're not square brackets. They're not regular brackets. They're just a straight up and down line. And whatever's inside of them, we only care about the size of it, not the direction it's going. So it ends up being a value that comes out without any sign. It'll always be positive. The negative would drop. So if x is greater than 0, then what's inside the modulus will just be what the answer is. If x is equal to 0, what's inside the modulus would just be 0. And if x is less than 0, so if something like -2, -3, then you want the opposite sign to that. You want the negative of that. So -2 would be positive. Basically, you can think of everything just becomes positive. Let's look at it with numbers. If you haven't written this down, then pause the video now so that everyone can get this written down. Okay, welcome back. So here you can write down as well an example that if you have modulus 4, it just equals 4. If you would have modulus 0, that doesn't change. That just becomes 0. But if you have modulus -4, then that equals 4. In physics, you'll run into the difference between scalar quantities and vector quantities. We also talk about them in math, but basically a modulus makes it something just scalar. I only care about how big it is. I don't care if it's going positive or negative. I want you again to pause the video and to see if you can write down some answers to these questions. So these questions are all basically state the value of something if it's inside of a modulus. And you have from A to G. And if you need reminding, there's a little definition here that tells us what the modulus function does. And you write down question 1, write down your answers, pause the video, and then when you're ready, we can correct our work together. Okay, you can pause it now. Okay, welcome back. So let's see if we can figure out what our answers should be for these. If you have something that's just modulus 2, it just equals 2. If you have modulus -2, that also equals 2. Inside of a modulus, if you have 5 minus 8, that would be -3 inside the modulus, but that just equals 3. If you have 8 minus 5, that also equals 3. E, F, and G involve a little bit more calculations, but the important thing to realize is that first you do the calculations inside, and the negative and positive matter inside, but once you come up with the answer, then you just take the positive. So for the first one here, for E, if you have 5 squared, you have 25 minus 9 times 5. So 25 minus 45 gives me minus 20, but the final answer would just be 20. For F, we need to realize that we don't distribute that 2 into the modulus. That's not a good idea. First, you do what's inside the modulus, and then you take the modulus signs off. So 2, and inside the modulus is minus 4. That just becomes 2 times positive 4, and so that equals 8. And for G, we have 10 minus what ends up being in the modulus, ends up being minus 50. That becomes positive 50, so 10 minus positive 50 gives us minus 40. So our outcome for this lesson is that we will start to understand the basics of notation for a modulus function and how they operate, how to solve some simple modulus functions. All right, now what I want you to do is, again, you're going to be pausing the video and you're going to make some groups of maybe three or 2 or 3. And I want you to discuss these 2 questions. The questions are, if I have 2 things added together inside of a modulus, is that equal to the one thing in a modulus plus the other thing in a modulus? And if I have 2 things subtracted from each other inside of a modulus, is that equal to the one thing in a modulus minus the other thing in a modulus? And what I want you to discuss together in your groups is the statement, is it always true? Is it sometimes true? Or is it never true? If you say it's always true, then you shouldn't be able to find any exceptions. If you say it's never true, then show me why it's never true. And if you say it's sometimes true, then you need to show, well, here it's true and here it's not true. Okay, so let's pause the video and give yourselves 5 minutes maybe to discuss this together. Okay, welcome back. Hopefully you had time to discuss, and let's talk about these 2 things. First of all, the positive one. If you have this something in a modulus, x plus y, is that equal to the x in a modulus plus the y in a modulus? Hopefully, you also came up with the fact that it is sometimes true. It can be true, but it can also be false. It would be true, for example, if you had something like 2 plus 3. That does equal the modulus of 2 plus the modulus of 3. But if you change that and you had minus 2 plus 3 inside the modulus, on the left-hand side, we would have a positive 1. On the right-hand side, we would end up with 2 plus 3, which is 5. So no, they're not equal to each other. So sometimes it's true and sometimes it's not true. How about the next one? If I have something x minus y equals something in a modulus minus something else in a modulus, is that always true, sometimes true, never true? Hopefully you also said that that is sometimes true. Here's a simple example. If I put into the modulus x is 5, y is 4, then I'd have 5 minus 4. And that does equal modulus 5 minus modulus 4. So sometimes it's true. But if I had something like 5 minus minus 4, then on the left-hand side, 5 minus minus 4, that would be equal to 9. But on the right-hand side, modulus 5 minus modulus 4 is equal to 1. So it's not always true. Okay, stay in your same groups and discuss again. Here are 3 more situations to consider. What about if you do multiplication? X times y, is that equal to modulus x times modulus y? Or if you have x divided by y all in a modulus, is that equal to the modulus of x divided by the modulus of y? Or if you have a bracket and then you have the modulus of x and then you square it, is that just equal to x squared or not? Pause the video, discuss with each other, and decide whether you think it's always true, sometimes true, never true. Okay, welcome back. Hope you discussed. In these cases, unless you found some exception I didn't think about, these three situations are always true. One will be equal to the other. All right, let's carry forward. What else do we need to know when we're dealing with a modulus? What we need to remember is that when we use a modulus, there could be two options for the x. So if I have something in a modulus equals k, and let's just assume k isn't negative because that gets confusing and isn't our situation that we're going to think about, there's two options for x. Either x equals k, or x actually equals the opposite of k, and the modulus signs changed it. Remember when we had the modulus of x is equal to 4, then it could have been 4, or it could have also been minus 4. So there were these two different options. So whenever you run into something in a modulus, you have to consider that what was originally in the modulus could have been negative or it could have been positive. And that leads us to, most of the time, have to consider two different options. So if you have something a little bit more, have a little more detail to it, like a simple equation like the modulus of ax plus b equals to k, then there could also be two options. You could have ax plus b equals k, or you could have that whole thing equals negative k. So how do we actually do a question when we have something like this? How are we supposed to lay it out? How are we supposed to notate it? What you need to do is you need to write out the two different options. So if I had the modulus of 2x plus 4 is equal to 8, then what are the two options we would write down? You can copy this down in your book if you still have your book open there. If I had the modulus of 2x plus 4 equals 8, then either 2x plus 4 is equal to 8 or 2x plus 4 is equal to negative 8. That's the opposite of k. Then as we solve it, we have two basic simple equations that we need to solve. If we solve 2x plus 4 equals 8, we know how to rearrange that, right? So we can work it out. 2x must be equal to 4, x then must be equal to 2. Well, what about the other equation? 2x plus 4 equals negative 8, and we rearrange that, we end up getting 2x is equal to minus 12, and then, oh, okay, x would be equal to minus 6. So we have two different answers for x. So what do we have to do with these two different answers? Do we just accept them? Almost, but first of all, in any kind of modulus question, you have to, first you write out both options, then you have to check your answers, and then write a conclusion. So what would it look like to check our answers? We take x is 2, and we put it back into the original equation, which was 2x, modulus 2x plus 4 equals 8. So if we put 2 into there, then we have modulus 4 plus 4, modulus equals 8. Yeah, it does. Or we check the other one. If x is minus 6, and we put that into the modulus, we have 2 times minus 6 minus 12. Minus 12 plus 4 equals minus 8, but the modulus makes that positive, so it's also true. So in this case, we've checked one side, we've checked the other side, and then we would write our conclusions. Therefore, x could equal 2 or minus 6. Okay, great. So you'll have some practice on ones like this in the next exercise you do. But first, let's talk about what if we have another step. What if we have a bit harder equation? Something like the modulus of ax plus b is equal to cx plus d, something with a few more terms in it. Well, in this case, there could also be two options. Either what's in the modulus equals the positive of the right-hand side, or what's in the modulus would equal the negative of the right-hand side. Now, whichever side it's on, it'll be true, but basically it could be positive or negative when you consider it was in a modulus. How will that look when we go to do some working with it? Let's try it out and see. So let's go back to our question, but just add a little bit to it. So if we have modulus 2x plus 4 equals 8x plus 1, then we have to write out two different options. We could have 2x plus 4 equals 8x plus 1, which is positive. And then we rearrange to be able to solve it. You can move the x's to either side, but if you move the x's to the left-hand side, you end up getting minus 6x equals minus 3. Hopefully you can follow that and see that x would then equal 3 over 6, or in lowest terms, 1/2. Well, what do you do if you have the other side? You write it out. So you say that it could equal this, the positive, or 2x plus 4 equals negative 8x plus 1. Remember to put the whole thing in brackets, and that negative affects both terms. So it becomes negative 8x, negative 1. I've moved the 8x over to the left-hand side. When you get together those x's, you get 10x, and you end up with 10x equals minus 5. So x could be minus 1/2. So we have x could be half, or it could be minus 1/2. Okay, great. Carry on to the next question, right? What are we forgetting? Remember, you have to check. You always have to check your answers. And then you have to make a conclusion. So let's check our options here. If I check x as 1/2, 2 times 1/2 is 1. So 1 plus 4 in the modulus is modulus 5. And on the right-hand side, I end up getting 4 plus 1, 5. Yeah, it works. Or x is minus 1/2. If I do that, I get minus 1 plus 4. Inside the modulus, that'll be 3. And on the right-hand side, I get minus 4 plus 1. That'll be minus 3. So does modulus 3 equal minus 3? So here you can see that positive 1/2 for x works. It checks. But negative 1/2 doesn't work. And so we would make a conclusion and say x equals 1/2. Doesn't equal minus 1/2 because the minus 1 doesn't work out. So equations with a modulus are not complete without checking and a conclusion. I think that's important enough that you should pause the video and write this down in nice big print across your notebook. Equations with a modulus are not complete without checking and a conclusion. That'll save you lots of grief in the future if you always remember, I have to check if it's a modulus. If you need to write it down, let's pause the video. Okay, welcome back. We're almost done the material that we want to talk about, and just want to note a little bit. There's a lot of practice questions you can try in exercise 1.4. And your in-person teacher will choose which ones you're going to do. Or you can choose for yourself if you're doing this independently. But remember, if you go to questions in number 3, you might have to factorize the quadratic into 2 brackets to find out what x can equal. If we have a quadratic equation and we're trying to solve it, usually we rearrange to make one side 0, and then we remember that in factorized form, if you have something like x squared minus x minus 6, you can equal 0. You could rewrite that as x minus 3 in a bracket, x plus 2 in a bracket, equals 0, and therefore x must be either 3 or minus 2. So for question number 3, you may have to remember how to do that. And in question number 4, you need to remember that when you have simultaneous equations, and in this case, in this question, they're both equal to y, then you can make them equal to each other, and then you can solve them. So like if you have y equals the modulus of 3x minus 5 and y equals x plus 2, then the modulus of 3x minus 5 must equal x plus 2. And then you need to solve giving the two options for the modulus. All right. We'll let your teacher decide what to assign you for those for that exercise. Let's just review here before you start working. A modulus function will take the value within the modulus and it will make it positive. For example, if you have some function where you have the modulus of x minus 8, and we evaluate, well, what's f of 1? That would end up being positive 7, not negative 7. Even though 1 minus 8 is negative 7, the modulus turns it to its absolute value. And then we talked about 3 different situations. If you have something in a modulus that equals k, there were 2 options. Either that was a positive k or negative k. And if you have an equation, either that thing in the modulus was positive or negative. And then even if you have harder equations where you have something in a modulus equals 2 or more terms, you can think that either those 2 or more terms would be positive or would be negative. Just remember to put the whole thing in the negative bracket and make sure that that negative applies to all the terms inside of that. All right, thanks for your attention. Have fun working on some exercises from 1.4 and have a good day.